All right, so we're gonna look at section, better pen, 9.3. All right, so a definition of a log. So what we have here is, let me show you how to read this out loud. We have log base b of x. So that's how we read that out loud. And these two statements are the same. So yesterday I was saying this right here is called log form. And this right here, yesterday, we said was exponential form. And we're gonna use this over and over and over today, which is good. So we get lots of practice. Okay, just to give you some things that this helps us with. So these tools right here, this definition is going to help us rewrite logarithms. So for example, say I have log base 2 of 16. What I'm really asking is 2 raised to what power gives me this 16? That's what it means in English.
4,
So-
correct?
Perfect. So like David said, it's 4 because 2, let me rewrite this. This translates to 2 raised to the 4th power. This is my exponent equals 16. So these two statements, they mean the exact same thing. Right? So a log is really an exponent. A log represents an exponent. So I'll say that'll be our chant. A log is an exponent. So that's what I was really trying to find. When I'm trying to find the log of this, right? I'm really trying to look for that exponent over here. So that's what a log represents. It's really an exponent. And so this was the big idea that we uncovered yesterday. And what I want to do is I want to give you some properties of logs to show you how they're useful. All right. So we're going to be solving logarithmic equations, and we're going to be using this definition over and over and over today. All right. So let's use this definition. All right. Any questions so far? No? Okay. So let's see. If I write over here, am I still in the camera?
No.
Nope, I'm out. But this you can see?
Yeah.
Yeah.
All right, cool. All right. So property number 1. So property numero uno. Here we go. So property number 1. Log base b of 1 equals 0. So this is one of our properties. And if I were to translate this property, if I were to translate it to English, all that means is when my argument is 1, this guy, whatever's in here, this is our argument. So whenever our argument equals 1, your answer is 0. So that's what you're looking for. This number right here, this b, as long as b, and I didn't write this down, but as long as b is a positive real number that's not equal to 1, this is going to be true. So whenever you see a 1 here, boom, your answer is 0. Let me show you why that's true. Alright, so let me show you why this is true. So if I were to rewrite this in exponential form, this is really b to the power of what?
1.
Or b to the power of 0. And anything raised to the power of 0 is?
0.
Not 0,
One.
but 1.
Oh.
So that's one of our exponent rules. Cool. So anything raised to the power of 0, bam, is 1. So this is our first property. And what you're going to see in the homework later on that I'm going to assign to you is that you'll get a question like this. Log, and I could put any number here as long as it's positive and it's not 1. So whenever the argument is 1, we already know because of this property that the answer is what? 0. So as long as you see that 1 there, that's where your focus is. Oh, that's a 1, boom, my answer is 0.
And what is the name of that right there? The one is?
Sorry, what is the name of?
The one? What
Oh,
is
the
it?
argument. Yeah, this is called, good, the argument. Alright, so there's our first property right there. So I call it property 1. Alright. Property 2. Property 2. Let's say that we have log, so property 2, log base b of b. So now we're noticing that the base and the argument are the same. Morning. So now we're saying that the base and the argument in this case are the same. So this is not what happens, but we could think about it like these guys canceling out. So the property says that this is 1. But let me give you the real reason. So this is the property. So if these guys are the same, the base and the argument, boom, you get 1 as your answer. And notice there's nothing else here. Here's the reason why. Right? This is log form. Let me change it to
The
exponential
answer's
form,
always gonna be 1?
even on Sunday. Right? So here's the reason why. My base is b. My exponent is
1.
1. And boom. My base is b over here. Or sorry, it equals b. Alright. So is b to the first power, is that equal to b? Does this 1 change anything?
No.
No, so this is true, right? So this makes sense, right? So in order for these to be equal, that means, remember when we don't have a exponent, there's an invisible what? 1. All right, so cool. So that's property 2. So property 2, all it's saying is when these guys are the same, they cancel each other out. Think about it that way. They're not really canceling each other out, but we could just think about it. So the way you might see it in your homework is, say you have a log that looks like this. And right away we see, oh, they're the same. So right away our conclusion is the answer is what? 1. So whenever the base and argument are same, boom, there's your conclusion.
Quick
So,
question.
yes.
Are you subbing for Jim's wife at Cabrillo?
No,
Oh, because I was like, oh,
she's at Gav. Yeah, Gav in college. Yeah.
that just dawned on me right now.
Yeah. Yeah, me too. I'm glad you said that. All right. So let's go with property number 3. Here we go. Property number 3. This time I'm going to throw an exponent in here. So go ahead and pick a letter, a variable for exponent.
Letter?
Letter.
Q.
All right, Q. So what's going to happen here, what the property says, is that what do you think is going to cancel out? It's not canceling out, but we could think about it this way.
The B's?
The B's, right? So whenever these are the same, our answer is Q. Okay. So let's look at this. Let's see if it makes sense. So notice this is a logarithm form. So let's change it to exponential form just to see if it makes sense. So
And
let's-
what are the name of the 2 B's on that one?
this is called my argument, or sorry, my base, and this together is my argument. So my argument is b raised to the q power. And I just put the q because that's what it suggests. But anything could be there. All right, so if I change this, so it's logarithmic form to exponential form, help me out. What's my base?
B.
B. What's my exponent?
Q.
Q, and it should always equal whatever this argument is. B to the Q. Cool, so it's true.
I thought you just equal Q.
Yeah.
No, this answer equals Q, but what I did is, this is kind of me showing you why it's true. Yeah, so this is logarithmic form, and this is exponential form, and I'm using exponential form just to show you why it's true. So b to the q power, yeah, that equals b to the q power. So that is true. Let me show you how we're gonna see this in the homework. Let me just pick one real fast. So in the homework, you'll see some questions that look like this. All right, and they'll say evaluate. And what do you see happens to the b's?
They cancel out.
And you're left with 3. Question.
Yeah, what if the base and the argument are different?
Great question. So the question is, what happens when these guys are different? And we're going to see those properties come up too. Cool. Yeah, we're going to see all that. Good. Yes, good question.
For the homework, do you want us to prove why it's true?
No, you don't have to. You don't have to do any of the proofs. I'm just showing you. That usually costs extra, but I'm doing it for free today. All right. Because sometimes people want to know why, which is good. You should want to know why. All right. So property number 4. Property number 4, and then we're going to use all these.
Wait, what happened to number 3? You already did it?
Yeah, that was number 3.
Oh, okay.
No, that was 3. Number 4, and I can take you. I can show you a picture early or later of number 2.
Number 2?
Yeah. All right. So b raised to the power of log base b to the x, excuse me. So notice in this one that b is my base, and this whole thing is my exponent. So make sure you write it small. So in your notes, make sure this is small. All right. So if you're watching this at Cabrillo tonight, make sure that's small, or else you're fired. All right. What do you think is going to happen here?
Wait,
What?
does that log also have an exponent?
This one, no, it doesn't have an exponent.
There's an X right there, or is that just the like?
That's the argument of the log. So this part right here is called the argument. So this is the argument. So it's just log base b of x. Yeah, but this whole thing
Is an exponent.
is the exponent.
Okay.
It's confusing at first, right?
Yeah.
It kind of takes some time to get used to it. It's just notation. It's like, what the hell's happening here? What is a log? Alright. So these guys, we could think of it as these guys cancel each other out. So all you're left with is that argument. Alright? And let me show you how we might see this in the homework. So in the homework you might say 5 log base 5 of 7. And now after this, seeing that definition, that property right there,
Oh, so it doesn't matter if it's log first or if it's.
Yeah.
Okay.
Yeah.
I got it
cool. So what's the answer for this one?
7.
7. Cool. So they're not bad once you understand kind of how to use them.
now. Yeah.
All right. So what we're going to do right now is we're going to use those 4 properties that I just showed you, and we're going to evaluate the following logs. Are we good so far?
Yeah.
All right. Cool. All right. All right. So let's do it. Let's do it. All right. And so let's go with using the properties. Let's simplify. So the only instructions you'll have is simplify the following. Log base 4 to the x plus log base 200 of 1. All right. So from the notes that we just took, what is this first piece going to become? What's going to happen to those 4s? They cancel, exactly. So from property number 3 that you copy down, from property number 3, these 4s, they cancel, and it just left you with the exponent.
Mm.
And then this next piece, what am I going to get from here?
Let's say 0.
0, right. So it's 0 because there's a 1 right there.
Yes.
So anytime this is a 1, we get a 0. So we just have x plus 0, x. So again, this was property number 1 that you guys used, and this was property number 3. All right, let's do another one.
Alright, that one's number 1, but there's nothing.
Yeah,
involved?
so whenever you have a 1 right here,
Uh-huh.
that's property number 1.
And then whatever is on the bottom, that's what's.
This guy, you totally you ignore it. You don't even need it. So right away, once you see there's a 1 right here,
Mhm.
boom, jump to that conclusion.
Yes, sir.
Yep.
You just have to forget about them.
What's that?
You just have to forget about them.
You forget about this because.
Oh, that's a 200.
That's a 200.
CERO.
Oh, okay. Oh, no, that's a 200. Sorry.
Alright.
Gotcha. Now I see. Sorry. All right, let's do another one. Log base 3 of 3 plus log base b of b to the third power. So here, let me make sure we separate these. Cool. So how'd you get 4? What'd you get for this piece?
1.
1, because these cancel each other out, right? So this piece is 1. So this right there just gave us that 1. And then this right here gave us what? The 3. So it's 4. So once you learn to play with these logs, like, alright, they're actually not too bad. But they're bad if this doesn't make sense. So let me know if it doesn't make sense. Alright, number 3. Alright, so that first piece, what's gonna happen with that first piece?
7.
Good, those 5s cancel, right? Think of it that way, good, so 7 exactly. And then minus, drop down the minus sign, what's of this?
1.
1, cool, because you're using what property? That was property number 2. So this is property number 2. When these guys are the same, man, it's just a 1. And then so we subtract and get 6. So I think those properties are okay, yeah?
Mm-hmm.
Alright. So, any questions?
What if the exponent is negative?
We don't ask those type of questions.
No?
I'm just kidding. Yeah, if the exponent is negative, it would just be negative. So say this exponent was negative 2, right?
Uh-huh.
Then we just put this as negative 2.
Wouldn't, because,
Then a negative will turn into a positive.
yeah, it's because, they said that you're not supposed to have a negative exponent, so you're supposed to put it on the bottom.
That's when we're simplifying exponents. So yeah, you're thinking of, and don't write this down, but you think like this, right?
Uh-huh.
So then we would simplify this as 1 over x squared.
Oh, okay.
So that's what it was referring to. Cool. All right. So those properties are going to come in handy. So those make sense. Let's add a few more properties to today's lesson. All right. So our next set of properties, here we go. We have those 4. We have our product property for logs. Our product property for logs. So we're gonna copy these down and then I'll show you how to use them. Alright. So log base b. So again, b could be any positive number except 1. And we'll talk about why not 1. Alright. So here's a product property. So let's say we're multiplying 2 products here. Right? So you have x and y. What this is saying, if you wanted to, you could rewrite this, you could expand this, you could make it longer. And there's gonna be a lot of situations where making this problem longer, like writing it out, is gonna be very helpful. We'll see where that comes into play. Right? But right now we're just getting all these skills. So this property is saying, hey, if I multiply 2 things, that's the same thing as adding them. All right, let me give you an example. So let's say you guys have done factoring, right, and all that good stuff. So let's say I'm going to multiply x plus 2 times, so the quantity x plus 2, and then x minus 3. And for some reason, I wanted to rewrite this and to stretch it out. Well, what this property says, and let me go ahead pick a number that's not 1, it's possible. 13. Alright. So what I do is log base 13 of this first piece, x plus 2, and I said whenever it's multiplication, it turns into what? Good, addition. Plus log, let me make a mistake, and good, so David copied. So you always need to copy down that same base. that base cannot change. So if this was a 7, 7 is 7. So notice what I did. I took each one of these mother factors, right, and we separate them. Boom. Right?
Could you use different practices? Because I think that's only personal, right?
What's that?
Could you use different practices, like use
Yeah, I could use right here if I wanted. I could use this right here, right? Absolutely. All right, let's do one more, just to make sure this makes sense. Let's say I throw in, so I think the other number you guys wanted was 12. So let's put X, Y, and Z, just to make sure this makes sense. So now, how many factors do I have in there?
3.
3. So how many logs do you think I'm gonna have? 3. So this always matches the number of factors. So that's probably another good note to have down. That if I have 3 factors, I'm gonna have 3, 1, 2, 3 logs. So yeah. So that's gonna be helpful a little bit later as well. All right.
They're supposed to be in front of, or one in front of all those letters, right?
There's invisible 1. Yeah. Yes.
So once you, let's say you have real numbers in there, like how does that FOIL out?
So you're saying X is not a real number?
No,
No,
I mean,
I'm just kidding. Good. Yeah, we're gonna use some numbers right now too.
Okay.
Good. Yeah. You know what? Let's just do it. Let's put some numbers in here. Just say I have 5x or something. Yeah. All right. Cool. So according to our property here, am I still on camera?
Yeah.
All right. This is log base 5. What's the first thing? First argument?
Log base 5.
Good. Plus log base 5 of x. And now we know, oh, what's going to happen here?
1.
Bam. If you forget, just think of me. Okay, number 1. And then plus log base 5 of x. Cool. Make sense? Excellent. All right, so that's our product property for logs. So now, since we have multiplication, there should be one that has what? Division. So we're gonna call that our quotient. Oops. All right, so let's look at our quotient property for logs. So quotient property for logs. And so quotient, we know it's just, we're dividing. So we're gonna have x divided by y. So if multiplication meant that you're gonna add, then you could imagine that quotient's gonna tell us to do what? To subtract. So quotient is gonna tell us to subtract. All right, so there's our property right here. So it's just saying whenever you have division going on, we go ahead and subtract. So let's go ahead and use that. So log, let's do an example. 7 x over 2 divided by x plus 3. Alright. So if we have that situation right there, then we're going to see, oh, this is just log base 7 of x minus 2. What's my sign in the middle?
Minus.
Good. Log base 7 of x plus 3. And it's subtraction because of this division going on. So this division tells us, bam, I got subtraction. All right, so now the next natural question would be, well, what does this look like when I put some numbers in here? So let's do that. So log base 7 of 49. So I'm gonna bring you back to yesterday's homework. I'll divide that by maybe square root of x. Make you look crazy.
Oh, so the other example, that's where it would stop?
That's where we stop, good, because what we're doing is right now we're just using this quotient property, we're not solving or anything, so good.
Or write it down?
We're trying to expand it, make it longer. Yeah, there's gonna be some cases where we're gonna condense it. And then we're gonna use both of those to start solving equations. Because what I might wanna do is, tomorrow, I'm gonna see you guys again, and we're gonna look at interest rates. So I'm gonna bring in a couple of examples of compound interest based on what we were talking about the other day. Cool. All right. Investments and stuff. So check this out. So according to this, we're gonna have log base 7 of 49. I have a division. Good. Minus log base 7. Is there another way of me writing the square root of x?
X squared.
X to the not squared,
Half power.
half power. That one's always a confusing one. So yeah, so the square root of x, just remember when you change it to rational exponents, is x to the 1/2 power. Cool. Because a negative would mean that we'd have a fraction, right? Cool. And we could actually still simplify this part right here. Let me, I think this is what we were working on yesterday. We had log base 7, and I said 49. There's another way of writing 49. That's 7 to what power? Good. That's 7 squared. Why might I want to write it as 7 squared?
Cause that would show.
Seven's cancel.
The 7's cancel. Good, and that's going to turn into a 2. Excellent. So now we're tying it into, what we had for homework yesterday. So our property states that these guys are the same, right? It just leaves me with the 2 minus log base 7 of x to the 1/2. Cool.
But is there any way to write that 2 to make it look like an exponent?
Say that again? This,
Yeah,
is there another way of writing it?
yeah, because that just looks like a regular 2.
It's
It's
not an
regular
exponent.
Oh, yeah, it's not an exponent anymore.
It is
Oh,
regular.
It is a regular 2.
Oh, it is?
Yeah, because these 7s, remember from property number 3,
Uh-huh.
says those guys cancel.
But why is the exponent changing to a regular 2 then?
Oh, because the property, let me write it right here. It says this, that let's say we have base b of b, let's say your exponent is x, right?
Oh, that's the property that.
Yeah. Cool. Alright. So there's our quotient property. And let's get one more for the day, and then I'm going to tie all these together. Alright. Cool. Good. So let's call this the power property. The power property for logs. And what this property tells us is that whenever you have an exponent on our argument, so let's see, let's do log base b, and let's say we have x, and then p is our exponent, so x raised to the p power. Alright, so what this property says is that this exponent, we're allowed to bring it to the front. So that's what the property allows us to do. Alright, so these two things are equal to one another. So this is called our power property. Just to show you how we could use it is, let's take a look at, I forget the numbers exactly, but let's say I gave you this right here. And I wanted to write it a little bit longer to expand it. So we just discussed how this is really x to what power? 1/2. Let's do this. Since you already know that's 1/2, let me put a little 3 here. What if it were a 3? Then it would be what?
1/3.
1/3, right? Just so you have another example in your notes. And so now what this property tells us is that what's going to happen to that 1/3?
It's gonna go to the front.
It goes to the front. And that's it. So you have 1/3 times that right there. And if you wanted to be cool and fancy and impress your mom on Mother's Day, you could write it like this. Right, just put the 3 on the bottom, but it means the same exactly. Oh, that's right. I gotta go get a gift. Today's my wife's birthday, so I had a big old plan, but then I got the text message and I was like, she'll understand, right? So I went. She teaches kindergarten, so I went to her. I was gonna take cupcakes and stuff and get the kids all fucking hyper, but I just went to go surprise her in class, but it was still good.
Wait, you get the kids?
Yeah, I got 2 kids. 2 kids. That's why we're all over the place. We're in Sacramento this whole weekend for a tournament because my daughter's in 3rd grade, but she plays on the 5th and 6th grade travel team. And so most of our kids are like 3rd graders and 4th graders. And it was cool because they look like midgets out there playing against all these big kids. But they won the tournament. So that's why I tell them, I was like, learn how to think. Once you learn how to think, then everything else with practice comes. Yeah, so that's the philosophy there. All right. So let's put all this together. All right. So what we're gonna want to do is you're gonna be given a log, and then we're gonna want to practice expanding the logs.
There's only 3 products of log, right?
3 parts, yes. Or you have your base, your argument, and that answer represents the exponent, whatever it equals.
I meant like product property, and then there's
The quotient property, and then the product. And then those other 4 that we had prior to that. And right now we're gonna use all of them together so you can see. Yeah. And then I'll have a summary that you can take a picture of right here after too.
Perfect.
Cool. All right, so let's use all these. So I'm gonna say for these examples, we're gonna expand log base 5 of 3x over the square root of y. So I wanna rewrite this, but I wanna write it longer. All right. So a few things are going on here. Number 1, you see how I have a multiplication right here? So multiplication means the 2 things are gonna be what? What's the product property? Multiplication changes to what? Addition, right? So these 2 are gonna be added, and when I have something on the bottom for the quotient property, it's gonna be subtracted. Are we in agreement there? All right, so here's the trick. I have 1, 2, 3 terms, so what I'm gonna do is I'm gonna rewrite all these, and then at the end, this is just the way I do it, I'm gonna slap some signs in front of them. Because each one of those is gonna become its own log term. Right? And these 2 are being multiplied, and you just told me when it's multiplied, it's addition. And this one is division, and the quotient rule says whatever you're dividing, the bottom term is subtraction. So here's your shortcut. Whatever one's on the bottom, that's the one that has a negative in front. Everything else has a positive. That's just a shortcut. Does that make sense?
So let's say the bottom was 3y.
Then the 3 would have a negative, and the y would have a negative. And we're gonna do that too. Perfect. So I think we're right there. Let me rewrite this, because now I have some more ammo. So now I know I could rewrite that y as y to the what power?
1/2.
1/2. Alright, so now I'm pulling out all the stops, all the tricks. Because I now know what's gonna happen to that 1/2. It's gonna move to the front, exactly. So I'm just using all the properties together. So this becomes log base 5 of 3 plus log base 5 of x minus 1/2 log base 5 of y. Or if you wanted to be fancy, just to have that over too. Bless you. All right. So are we all right there? All right. So let's do another. So same type of question.
Don't erase the bottom.
The bottom, that's there. Cool. So we want to expand again, and we're gonna have log base 4.
Quick question.
Yes.
John, for
Quick answer.
this one over here where it says -1/2, should it be -1/2 times log?
When it has 1/2 and there's nothing there, there's an invisible multiplication.
Okay,
So,
so it's implied.
yeah, it's implied, good. All right, so for this one, take about 10 seconds and see what you come up with. Just rewrite it, and then I'll check in with you. All right, so take about those couple seconds.
We have 7.
Oh, wow, time flies. All right, so how many log terms did you end up with?
3.
3, cool. So this is log base 4 of 3, help me out,
Plus,
plus log base 4 of x, help me out,
minus,
log base 4 of 64. Alright, so again, we only put the negative sign, that minus sign, in front of the one that was in the denominator. But now, thinking back to our homework, I could do some creative steps here. I could rewrite that 64. That 64, I could rewrite it as 4 raised to what power? Gives me 64.
To the cube.
So 4 cubed, bam. And why did I rewrite it like that? What's about to happen now?
cancel that.
It's gonna cancel because of our property. That's property number 3 that we copied down earlier. So now, this is just a number. This is log base 4 of 3 plus log base 4 of x minus 3. So right now, we're practicing expanding these logs, making them longer. All right. Excellent. So what I have here is you're gonna be doing that for homework on 3 of those. All right. So now let's go backwards in our last 5 minutes together. All right. So this is called expanding logs.
It's on 20%, so it's stopped.
Oh, stop. Can you hit record again, por favor? Did it just stop right now?
Yeah,
Perfect.
it's third grade.
Okay, cool. All right. So I'm in sync with the low battery mode. All right. So now what we're gonna do is I call this condensing logs. So we're gonna condense these logs. So we're gonna have multiple logs, and our goal is you wanna write these as one single log. That's gonna be the goal for these. All right. So let's look at this first problem. 1/4 log base 19 of 17 minus 2 log base 19 of y minus log base 19 of x. All right. So we'll actually end with this example. So make sure you ask questions if you get stuck. So what we're gonna do is I can't do anything until these logs don't have a coefficient, but these coefficients are messing me up. Is there anything I could do with those coefficients?
You can put them in the front.
They're already in front, I could put them,
You have to.
In-
Exponent.
yeah, that's it.
good. And what property is that?
The subtraction is under the.
Good. So I'm gonna do one of these things at a time, you guys are absolutely right. I'm gonna use the power rule first. So the power rule, just like you heard, is saying that the coefficients go and they move as exponents. Right? So that 2 becomes an exponent. So the first thing you heard is we use that power rule. And now we know that these can transform into one log because they all have the same base. So remember, they have to have that same base.
Oh, and if they don't, then it's 2 different bases.
Exactly. Then we can't combine them because we talked about earlier. It's all about that base, about that base, about that base. So this turns into log base 19, and let me set the scene. Right, I know I'm going to have some division going on. What's telling me that I have division going on?
Subtraction.
The subtraction, good. So now I know that I'm gonna have the what root of 17?
4.
The fourth root. And the reason it's a fourth root is because this guy's a fraction. So make sure that's clear in your notes. What's going on the bottom here?
Y squared x.
Good, y squared, and then perfect, times the x. You don't need the dot, but just emphasizing it.
Wouldn't it have to be under y squared because it is subtracting, because if it's multiplying, that's adding?
So this, good question, the subtraction here means these are all the terms that are gonna go on the denominator.
But on the other one, we said that 3 and 7 were multiplying, that it was minus 3 plus 7.
On which, the last example?
Yeah, wasn't it? Well, we didn't write it out, we just said it.
So this is what, just to clarify,
Uh,
this minus, you can write it like this. Don't copy this down, but let's just think about it. The fourth root of 17, you're saying, or you're cool with that y squared, right?
Yeah.
But this one, it is negative, but if it were to be a fraction, it would be up here, 1 over x, and then the x would move down there. Yeah, it's weird. So here's a shortcut. Whatever has the minus, just move it to the bottom.
So if it's at the bottom, it was minus.
Yeah,
Okay.
exactly.
Alright.
Cool. So that's gonna be the easiest way to think about it. All right, so now I just have one log. So that's as simplified as it gets. So what you're gonna do is, I have a picture if you missed. This is gonna be the first page. I'll put them in order for you. These are gonna be the properties, if you need a picture of them. And then the ones that I didn't do in class, just complete for tomorrow. And that'd be great practice. So I could continue talking about logs and their applications. Cool. You press pause for me? Thanks.
You want us to grab all three of those?
No, sorry, I didn't make